I will be speaking about trends in securing election technology. These are trends that are global, which also means that they affect different countries in different ways, because all countries have some differences, at least in their election systems, both in paper form and in technologies as well. And I will handle both past trends a little and, more importantly, trends that we will see more importantly in the future. But all of these are related to technology, but these are mainly not technological trends. They are about technology, but very few of them are actually technological trends. So who am I? As Dan said, I'm a senior information security specialist. I do have some certificates as well, but mainly I have been working quite a long time in security and a long but not as long time in election security. I have actually seen this world beyond Finland, because I have spoken a lot, I have traveled a lot about this topic, and I also have worked in many committees for handbooks, guidelines, and so on. So that's why I'm speaking about trends that transcend the national boundaries. But where I work is a weirdly named authority that is the Legal Register Center of Finland, but we are basically the IT arm of the Ministry of Justice. So we handle whatever the Ministry of Justice and its agencies handle, but we are an IT organization. So my background is in IT, and my organization is the IT arm of the elections as well. And we do, in Finland, run several election-related information systems that are all under our agency. We have the election information system that is somewhat similar to the Estonian one. We have a system for registration for postal voters. Everyone else doesn't need to register to vote. And we have a registration system for creating new parties, and some other smaller systems that we actually operate. But let's start with the past trends. What we have seen since about 2016, when people actually, at least at that point, started to care about information security in the election sphere. Of course, people should have cared about it before that, but since then, countries have really noticed that it's important and have put a lot of effort into securing elections. So I start this slide with a quote from an actual old slide of mine, which is a long list of all the traditional technological stuff that we now take for granted that it's in elections. It was not always so in every country, but even before 2016, some countries put really a lot of effort into this side of election administration. But now, since what has been happening in the world, most election administrators, at least, have actually noticed a few things. They have realized that election information systems that they have had for a long time, the first election information system in Finland is much older than me, but they have realized that those systems are actually information systems, which means that they need to be run like information systems. And they have realized that the information actually needs to be secured, especially if you have that information in an information system connected to the internet. And actually, they have realized that this is business as usual for at least everyone who is not an election administrator, because everyone basically in the world runs information systems, and This is business as usual, no matter what is your actual business. And that also means that there are good standard ways to do all of this. Of course, those good standard ways are not static. They evolve all the time. They evolve because of developments in technology, developments in legislation, and developments in actual management of technology. So even though you might have picked up a good way to do things, it's not static. You need to update it all the time. And also, election administrations at least have realized that weaponized disinformation exists and is related to elections, so that needs to be countered with transparency. This is something that not everyone who runs information systems needs to do, but election administrators have pretty much realized this. We have also some things that are very special to elections. Some of these are very much related to information systems, but many of them are about elections as elections. Of course, elections are a very high visibility target, so there needs to be lots of resilience, and they are also very time critical, so you need to do all of the things that are needed for high availability information systems. They have multiple stakeholders, so you are actually managing multi-organization thing when you are managing elections, because there are suppliers for pretty much everything. There's multiple agencies, there's media, there's the candidates and parties and so on. What happened in 2016 was that actually people started to target elections, and that is why this change has happened. So it's an interesting target for adversaries as well. And the processes are pretty much in every country, in both physical sphere and information system sphere. So it's a hybrid system pretty much everywhere. So attacks can happen in any of these spaces. You need to secure all of them. But also, all of the guidelines and standards and good practices about how do you actually run elections apply to information systems, because democracy is essential, and the information systems that we use to run the elections are an essential part of the elections. So we need a lot of things to do to build actual trust in the systems. So now we move on to the future trends. And I will start from one, but these are actually somewhat related and building up to the very last trend, and the closer we get to the end, the closer we are to the overall theme of this presentation. But now we're at the beginning and the furthest away from the overall theme. So actually, government systems are not the easiest targets because of all the work that governments have done in the past years to secure the government systems. So even if you did not have a good systems in 2016, you have done a lot of work to secure them. So those are at least somewhat secure. Maybe not perfect, but at least they are not the easiest target. But there are a lot of other stakeholders in the election space that actually have their own information systems that might not or might be related to the government systems. There are, of course, candidates and parties. There's media. There's lots of service providers, not only for the government, but to all the other stakeholders as well. And in pretty much every country, there's also some kind of subnational level of organization that is involved in the elections, whether it's some kind of regions or municipalities. There's some kind of local or semi-local government And of course, all of this is widely known. And of course, the threat actors in this scene know all of this and use it. So the most recent attacks in Germany were not to the federal systems, they were to party systems of two quite big parties this summer. And that means that governments need to be able to support all the other stakeholders, securing their own systems. But some of them might not want that support, so it's a hard challenge with some of them. But it's also something that is different from running government systems, because for instance, in one of the German parties, the membership roles were breached, and that meant that party was not able to nominate candidates according to their rules. So weird interactions because of the complexity of the organizations. This is something that affects mostly the countries that rely on postal mail in some parts of their elections. Postal voting is big in some countries. We are not one of those countries. And I think Estonia is not one of those countries either. But globally, the use of postal mail is in decline. It's affecting postal deliveries everywhere. So it means that post takes more time, and there's less mail overall, so it's easy to identify which of the envelopes are actual votes. And access to postal mail is getting harder because post offices, letterboxes are starting to disappear. This might also, besides postal voting, affect if you have polling stations abroad, because those might use postal services to send the votes home, or it might not. This is quite rapid change that we are used to in the IT space, but not in the physical space. This might lead into some countries looking into iVoting, which is not that far adopted, but this might be, for some countries, the reason to start using it, or at least start looking into it. This change has some similarities to what is happening with the end-user devices, where people are increasingly starting to use only mobile devices instead of computers. But that is surface level similar change, but very different in its details, and especially when you consider how it affects each individual country. It affects you less if you only use for voters the websites to distribute information, because that's easily adapted to mobile devices. Of course, for election authorities, they are likely to use whatever devices we give them, so this change is not for them, but only for the voters. Post-quantum encryption was a big theme today. For very good reason, it's a big theme right now, but it's actually two very different hard problems. There's the security of the existing data, and it's in quotes there because it might also mean that it's data that is signed to be existing in the past, but it's actually not. So asymmetrically encrypted data can be captured now, and it can already be captured. It can be decrypted later. It can be any data that is in a place that is reachable by the attacker, so that might be different places for different attackers, and especially in different countries. But it also can be digital signatures that might be in the future created to be signed in the past or by someone else in the past. So this is the security of the existing data, existing systems. But also there's a transition to using quantum safe algorithms, which is very different but very hard as well. So there are so many technologies that we actually use. Anything can be the weakest point, and almost everything needs to be updated somehow, or at least checked if it's vulnerable. It usually is. Of course, we have the new standard post-quantum algorithms that have had years of study and have not been broken so far, but that's only a few years of very good analysis. So because of that risk that there might be breaches in the near future, the recommendation is to use hybrid algorithms that combine both post-quantum and existing algorithms. Which is usually a very good idea, but it's very usage-specific if it's a good idea. So the more common a use case is, the more common library or piece of software that uses hybrid encryption, the more study will be put into that, because implementation details vary. But of course, the more these technologies are used, the more they will be studied. But does that include all of the technologies that are used in elections in very specific election things? So who is the one who will be doing all of this work and analysis? That might be a problem if the use of encryption is very specialized in elections. And that is very much related to the fact that the math required for the post-quantum algorithms is much harder than the math required for current asymmetric encryption algorithms like RSA, which is taught in Finnish high schools. You can do it actually on pencil and paper with very small numbers, but still. But with post-quantum encryption, the pool of people who can actually study the algorithms and implementations in detail is much smaller. So it's very much also a management problem. Also, we have lots of new regulation coming from many sources and also for very good reasons. We have the international stuff. We have GDPR, NIS2, and so on. We have national laws that might or might not deal with election security. We have also the intergovernmental recommendations, guidelines, and so on. We have the Council of Europe guidelines, which actually tie the use of information systems and the management of information systems to the principles of free and fair elections. So very election-specific there. And we have the European Union Compendium on Security of Election Information Systems. And some of these are general cybersecurity, as we saw in the first slides. Good stuff that everyone is doing when they are running information systems for any purpose. We have risk management, we have actual management, we have policies, reporting, encryption, supply chain security, we have security testing. These are things that are for everyone who does anything with IT. They are technological recommendations, technological legislation. They are also organizational stuff there, in many cases in the same piece of legislation as well. But some of this is actually very, very election-specific because the principles of free and fair elections do touch this stuff of running the IT systems. There's also interagency collaboration, which is important because of the multiple stakeholders in elections. Transparency is not as apparent in other spheres as in elections. There's also requirements for how you actually operate and assess security of election-related systems. So lots of more regulation coming in from different sources that we need to tackle. And moving on, all of this actually touches two very different and conflicting parts. We have the need for transparency, on the other hand, for building trust in the systems. We also have the need for secrecy to actually secure the systems, and these need to be in balance. It's not a one decision, it's a constant stream of small decisions related to every piece of technology, every single use case, everything we do when we run information systems for elections, that we need to make these decisions because, for instance, there we have the Council of Europe guidelines and what they say about building trust in elections and election information systems. And of course, this building of trust needs to be done in a language that the voters can understand. But these two interests need to be balanced, and that's actually my main contribution to the Council of Europe guidelines. This balancing that affects pretty much every point in those guidelines. And some of this balancing can be done by a decision, and some of this balancing is done by your system architecture. So you can decide that you will, for instance, open your source code. That's just a decision you can make. But also, if you have an information system connected to the internet, that exposes a lot of the technological choices you have made to anyone, whether that was a conscious decision or not. So lots of information is necessarily public if you are kind of connected to the internet. So these questions are something that needs a lot of expertise and transparency in this process itself as well. But this coincides with other trend that means that everything connected to internet is very vulnerable to fast exploitation. We, in the past, might have had the idea to build a secure system and audit it and leave it running as is for many years. Now, we need to be able to update those systems in a few hours when there's a vulnerability found, because no one can make an information system that is connected to the internet and does not use standard commercial technologies. They're always there in some format. You can make that part as small as possible with system architecture, but you can never eliminate this need totally. So the audit and certification cannot be only for a static system, because it needs to take account that the systems need to be patched in very short times at times. So this needs to be taken into account in the auditing process, and the overall security cannot rely on just a static audit. And also means that the trust cannot be built only on the audit results. It needs to be built on the processes and the actors that actually run these systems and operate them. And this comes to the conclusion that this is more a management problem than a technology problem. There are multiple hard problems that require expertise in many disciplines because there's math, there's technology, there's cryptology, there's elections, and very few people are able to operate in multiple of these domains. There's also many people, many organizations that are running this stuff, including all the parties and the media and so on. So there needs to be a lot of collaboration. But also there needs to be a lot of communication about this to the public to build the trust. And all of this needs to operate fast so that we can respond to vulnerabilities and incidents in a short time. Because elections are fixed in time, we cannot move the elections easily. And we can never outsource the responsibility. We can outsource a lot of the work, but TMBs, the election management bodies, they actually need the competence, not necessarily to do all of this, but to manage all of this and do all the technology-related decisions. In every single part of the life cycle of all the information systems related to the elections that the government runs. And that is a lot of phases and lots of different skill sets that are needed. And this list is actually getting longer and longer because of all the things mentioned in the previous slides. That means that the required level of competence in management is also getting higher. And to identify what else needs to be in the list in the future, the horizon scanning needs to be a big part of this as well. It's a part of the technology management, not part of the technology itself. And we have a couple of minutes for questions as well.
Let's thank the speaker. We do have a couple of minutes for a question or two. Depends on the length of the question. Anyone? Yes.
Thank you for the presentation. On the first slide, you mentioned that your organization has about 200 employees and what, €100 million budget. Can you estimate roughly how much of this is dedicated to managing the election system specifically?
I don't have the election system figure. We spend about 8 million in elections itself, but that includes all the paper processes as well. So all of elections is 8 million a year.
Thank you. One more. Not right now. Thank you very much. Thank you, Juha, for taking the trip.
Thank you.